In this example 2, I'm going to show you how to find the natural log of the function when your u here, we call it an argument. U calls the argument, where u itself is a function of x, or u is a complicated function. So if we have y equal to ln of u, where u is complicate, then y prime is 1 over u times u prime, which is I'm using the chain rule to get. So multiply the chain rule, and u's mean the argument. And u pretty much a nasty function other than x. But in the case here, I call it u. So if you look at A, this 3x here can be called the argument, and this argument here is a function of x. It's a 3x, it's something more than x. So therefore, when you find y prime of this function, we have to use the chain rule. So y prime will be 1 over, this is my argument, 3x. Multiply the derivative of 3x is 3. By using the chain rule. The key is, if your argument is anything other than x, then you have to use the chain rule. That's it. Or you have to remember this formula. So 3 cancel out, I have 1 over x. B. Looking for y prime. Once again, I have ln of x squared minus 5. This is complicated than just x. So right here is my u, or this is my argument, is complicated, so therefore I have to use the chain rule. So y prime, the derivative of ln of something is 1 over the argument, which is x squared. Here I'm using this rule. So 1 over the argument. Multiply the derivative of this guy, which is 2x. So I have that 1 times 2x is 2x over x squared minus 5. I'm done for B. For C, I have f of x equal to ln of ln x. This whole thing here. This whole thing here is my argument. This whole thing here is my u. So therefore, f prime will be 1 over the argument, which is ln x. Now because my argument is a function of x, therefore I have to use the chain rule, or complicate, by multiply the derivative of this, which is 1 over x. So now I have to simplify. I have 1 times 1 is 1. X times ln of x is x times ln of x. Please remember, this x here belongs to ln. You cannot say take this x times this x. You cannot do that. So just put the x in the front, this time ln x. So this is our answer. Part D, looking for f prime of ln x equal to ln of x to the q plus 4 over x. Now we can do f prime of this function here by using the chain rule directly if we want, but it's quite nasty because I have to use the quotient rule. So the best way I'm using the natural log property is say ln of m over n is same as ln of m minus ln of n. So therefore I rewrite the function f to look like this, where m is 3x to the cube plus 4 minus ln x. So now it's easy for us to do f prime. So I put 1 over x to the cube plus 4. Because my argument here is complicated, I need to do the chain rule, so I have 3x squared. Then the 4 is 0, so we don't have to write it down. Minus 1 over x. Now we write this as 3x squared over 3x to the cube plus 4 minus 1 over x. Then now we have to simplify. I see to simplify this here, these two fractions, they have a different denominator, so we have to find LCD. Our LCD is x times x to the q plus 4. So this term here I need to multiply by x, and this guy here I need to multiply by 3, x to the q plus 4, and please remember to do exactly in the top. So this here I can rewrite as 3x to the q over, because I have 3x squared times x, so I have 3x to the q over x times x to the q plus 4 minus 1 times this guy is itself over our LCD. Now we can subtract them because they have a common denominator. So we have, I keep a common denominator, so they copy it down. Here's our common denominator. Take 3x to the q minus. So please remember this is minus the whole thing here. So the safe way is to put like this. Then now we can rewrite again. So I distribute the minus inside. So I have 2x to the q minus 4 over our LCD. So this is our answer when we simplify.